Good morning, everybody. Thank you for joining us for this webinar about PFAS. I think we will start because you're on time, so it's just normal to start now. And if people come in, I will let them in. Today, I'm here with two of our speakers. First, we'll have Andrea and Sarah. Sarah will start and talk about really interesting thing, and Andrea as well. Here is our agenda. So we will start with this topic, which type of packaging are most affected, and then following with a little Q&A at the end of this presentation, and then come back to our second speaker, and we will talk about why are PFAS used, where are they found, and at the end of this one, we'll also have a little Q&A. Some practical information. We record this presentation, this webinar, so you can also find a replay online on our website in a few days. And also, we will send the presentation to you also in a few days with the link of the replay. So I will let the floor to our first speaker, to Sarah. And also, you have the opportunity to ask your question in the chat. So don't be shy. You can type in the chat your question, and we will answer it at the end of each presentation. So Q&A via the chat. And now I'll let the floor to Sarah.
Thank you, Aurélie. Good morning, everyone. Can you see my screen?
Yes.
Okay, thanks. So we'll start with an introduction on PFAS, mainly focused on packaging. PFAS are per- and polyfluoroalkyl substances, so it is a group of substances. They are synthetic, meaning they are man-made. They have been in use since the 1915, and the group is containing substances with strong carbon-fluorine bonds. As you can see on the picture here, you see a molecule out of carbon with fluorines that have replaced the hydrogen molecules. That strong carbon-fluorine bond is their common characteristic. It is something that makes sure that the molecule is very stable and gives the molecules properties that are highly desired from a technical point of view. But they also make sure that the PFAS are persistent. For regulatory and analytical purposes, a good definition of the group is needed. Currently, the most accepted definition is the one proposed by the OECD in 2021. And this one is also the basis for the definition used in the PPWR and in the REACH restriction proposal. Here, PFAS are defined as fluorinated substances that contain at least one fully fluorinated methyl or methylene carbon atom without any hydrogen, chlorine, bromine, or iodium attached to it. Both the PPWR as the PFAS restriction proposal from REACH have some exception on that description. So we have a broad class of chemicals with a variety of molecular structures, physical, chemical, and biological properties. They can be polymers, non-polymers. There is a variety in chain lengths, in degrees of fluorination, in volatility, solubility, and so on. So there are many ways that you can group or subdivide the broad PFAS class in subdivisions. But the one that I want to discuss with you today is the subdivision from the REACH restriction proposal, because here it has been used for the impact assessments of the different subdivisions. There are 3 subclasses. The first group are the classic PFASs and their derivatives. They are having short to long chains and can be solids or liquids. The second group are the fluor gases, so they are gases or low boiling liquids. And the third groups are the polymers. They are thus long molecules and are hard or rubbery solids like Teflon. Now to the properties. As I said before, the stable carbon-fluorine bonds of the molecule leads to useful properties from a technical point of view. Some of these properties are durability under extreme conditions, thermal stability, resistance to chemicals, radiation, and pressure. For instance, that is why they are used in flame retardants or solar panels. PFAS also cause water, oil, and dirt repellency, which gives application in non-stick cookware, textile, and furniture. They are also used as surfactants, for instance, in inkjet printing, and they have electrical and thermal insulation properties. So we see that they are used in a various amount of industrial application and sectors, but also in household application. This means that at the moment, PFAS can be found everywhere. I added this picture just to show you how widespread the applications are. You can find them in our daily life, for instance, in our food contact materials, cosmetics, and electronics. Everything that contains lithium-ion batteries has PFAS in it. When we discuss the application of PFAS in materials, we should have to make a distinction between the intentionally added and the presence of PFAS. The intentionally added PFAS are added on purpose to achieve or improve certain properties. When we look at cardboard, for instance, we see that PFAS can be used to give the paper fat repellent properties. But it can also be unintentionally added or present, sorry. For instance, by contamination of the recycled paper, contaminations of processed water, or contacts with lubricants in machinery during the production, detergents. There are many ways that PFAS can enter unintentionally in our materials. When we look closer at the packaging application, the list is not limited to what I show here, but some known applications are food and feed packaging, mainly focused on paper and cardboard and plastics. There is also semiconductor packaging and medical and pharmaceutical packaging. Now, in the last group, we see that it's mainly focused on polymeric PFAS, which are a bit more stable, but are still part of the PFAS group and thus can lead to contamination with PFAS of the environment. I'll give some examples from paper and paper boards, and then later on from plastics. And paper and boards, we see that PFAS are applied to give oil and water repellency, to improve barrier properties, and also for heat resistance, as we see in the baking paper or microwave popcorn bags. Most paper and board does not contain intentionally added PFAS, but as I said, for some applications, it is added to give oil and grease resistant or water and vapor repellency. PFAS can be added in the pulp or as part of coating formulation. Something to mention here is that the Single-Use Plastics Directive leads to the use of more molded fiber articles to replace the plastic throwaway packaging. Now, those molded fiber applications are known to use PFAS as an impregnation technology. Not that they are all PFAS impregnated, but it is a known technology. So, for instance, for food containers, drinking straw, pizza boxes, there are applications where PFAS are added. Then to the plastics. Some of PFAS applications in plastic packaging are as processing aids in the extrusion of films. For polyolefins, PFAS are used to reduce the dye buildup. They are used as a mold release agents. They can be added to create a moist barrier. And of course, there are the fluoropolymers. And you can find them in packaging for foods, cosmetics, household products, pesticides, and chemicals. Now, from the list, I have a more detailed example. There has been publications from the EPA that found PFAS in pesticides. Now, when they trace back the origin of the PFAS in the product, because it was not intentionally added in the products, they found that the cause was the packaging. As for packaging for dangerous goods, fluorination is actually a known process to improve the chemical compatibility so that the material is more resistant to the chemical that it will be containing. Here, the material is treated on the inside with fluor gas, and PFAS are actually formed as a side product. But thus, since there is contact with the pesticides on the inside, they are being contaminated, and thus the pesticides with the PFAS contamination are spread over the fields. Now, a bit about the concerns of PFAS. PFAS are grouped as substances that have a persistent character themselves or can to degrade in persistent PFAS. They all have a form of mobility, so they can cause contamination of groundwater, surface water, and soil. The persistence is related to that strong carbon-fluorine bonds and makes that they can accumulate in environment, drinking water, foods, and even human tissue. That's why they are called forever chemicals. So PFAS represents an environmental and human health hazard. We humans are exposed to PFAS in several ways by our consumer goods, firefighting foams, foods, just because moving in our environment. And it has some harmful effects. Some of those effects that we have, that are found in general, are increased cholesterol levels, cancer, effects on fertility and fetal development, effect on liver and kidneys, and they are also suspected of interfering with the endocrine and immune system, meaning that they can cause vaccines to have less effect. Some risk assessments have been done. I will quote some points from the REACH restriction proposal and a Belgian market study from 2023 on the use of PFAS. The REACH restriction proposal states that the European Economic Area has a top 5 of segments of which packaging is a part, concerned about the PFAS use in product manufacturing. In the Belgian market, 70% of the volume of PFAS use are covered by segments other than packaging. So there is a little distinction between the European and Belgian markets. Though the good news is that for packaging and especially food packaging, there are found some viable alternatives for PFAS. So it's most likely that it's easier to phase them out in packaging than in some other segments. Go to the regulatory measures. In general, we see that only a few out of the 1,000 PFAS compounds are regulated on a global and European level across different regulatory fields. Of course, packaging and packaging waste is now a bit an exception on that, because that one tackles the entire PFAS group. Different regions and countries have different approaches to regulate PFAS and have different limit values. PFAS restrictions within the European Union are primarily focused on intentional use and are being published or upcoming. Now, in the European Union, those measures are in the framework of the European Chemical Strategy. The Chemical Strategy for Sustainability is published in 2020. It covers actions to ensure safe and sustainable chemicals for health and the environment. And a part of those actions is phasing out of PFAS in the EU unless their use is essential. In the EU and applicable to packaging, the main regulatory measures are the PPWR, the restriction proposal by ECHA, and of course we also find some of the PFAS molecules listed in Annex 1 of 2011, which concerns the substances that may be used to produce plastic materials for food contact. Now, both the PPWR as the ECHA restriction proposal have some limits on the content of PFAS in materials. There are 3 categories: limit value for individual PFAS, limit value for the sum of individual PFAS, and then a limit on the entire group of PFAS, including the polymeric. More on those differences from the analytical point of view will be given by Andrea. But when we then look at the PPWR, there is a PFAS restricted on food contact packaging, and here compliance should be gained against the 12th of August of 2026. The restriction proposal is still a proposal and not yet under force. It is under REACH and called the Universal PFAS restriction, as it covers different sectors and groups instead of individual substances, and covers both production and use of it. The PPWR is applicable to all packaging and all packaging waste. The concentration limits for PFAS are valid for food contact packaging placed on the markets. And it defines food contact packaging as what is under the scope of Regulation 1935 of 2004, And here the definition of a food contact material is materials and articles that in their finished state are intended to be brought into contact with foods that are already in contact with food and were intended for that, and can reasonably be expected to be brought in contact with foods. The REACH restriction proposal. The proposal has been published in 2023. It is a document of over 2,000 pages and contains risk assessments, concentration limits, and a proposal for transition periods and derogations. Following the normal procedure of a REACH restriction, it should have been finished by 2025, so actually now. But as this is, of course, a very complex dossier, the evaluation is still ongoing, and an updated restriction dossier has been published recently. So to conclude, PFAS are being used to improve properties and performance of materials and articles for specific uses. The PFAS class is a broad class of chemicals with many and diverse applications. Intentional use of PFAS can negatively impact sustainability principles, as for instance, materials after recycling can still contain PFAS. For certain applications, the use of PFAS can be avoided, or PFAS can be replaced by other chemicals, but for others, this is currently a bit challenging. Regulatory measures are being established with PFAS bans, especially for non-essential uses. So this is the end of the presentation. I'll give the word to Andrea for the next part, I guess.
First, the questions. We received some questions in the chat, in the Q&A chat. So I will ask them to you. The first one is, by eliminating plastic from packaging and going rather to paper solution for food, we increase the use of PFAS. That's the question.
That's not really clear because, yeah, even in plastics, PFAS were being used. So what we see both for paper and board materials as for plastic materials is that producers are finding alternatives for the use of PFAS. So in the end, it is the idea to ban PFAS and go to solutions that are PFAS free. But there is no clear view on whether the increase of paper and board material will lead to higher levels of contamination as we introduce changes in the legislation. But it is a fact that the most PFAS levels are found in paper or molded fiber articles when we compare it to the plastic alternatives that there were before.
Okay, thank you. And we have another one. Are PFAS restriction in PPWR focused on intentionally added PFAS or intentionally and unintentionally presence of PFAS? Today, this is not indicated in the PPWR.
No, in fact, we see those three concentration levels. And then when you look at the values for the targeted PFAS, you see that these are lower. So yeah, that is, I guess, more focused on the intentional use because the contamination and thus the unintentional use are more covered by the group analysis by organic fluorine.
And in line with this question about PPWR, does this include packaged food products entering the market as well? So PPWR compliance to PFAS by 12 August 26. Does it include packaged food products entering the market as well? I don't know if that's clear.
Yeah.
Okay.
Well, when you look at the definitions, I would say yes, because in Regulation 1935 of 2004, it is stated that also packaging already in contact with foods that was intended for it is a food contact material, and PPWR refers to the food contact application of to that definition in 1935 of 2004.
Okay, good. Thanks a lot, Sarah, for your presentation and for answering the questions. Thank you very much. It was really interesting. So for that, thank you.
You're welcome.
And now we can go on with the presentation of our next speaker. So I let the floor to Andrea this time.
Thank you, Arlie. Thank you, Fost Plus, for the presentation. Thank you, Sarah, for this part, because it helps me to share and speak about what I try to explain. My presentation is divided in three big parts. The first part is in connection with what are the testing, what are the technology that a laboratory use to identify and try to discover the PFAS. The second part will be more related to the mobility proofs of concept about a study that we did last year on the paper recyclability and composting. And the third one is the potential shift to other material. What happens if I change my material from a PFAS additive to another one? The first three slides will be a little bit overlap of the Sarah presentation, because give a sort of introduction to the technical and analytical investigation, because all the analytical investigation that I will explain you later are a mirror about what are the use of PFAS and what are the restrictions. As Sarah said, there is a strong presence on PFAS in packaging. Some of these PFAS used in paper, fiber-based, usually are no, and they are working to exchange in the last year. But in other kind of matrix, the knowledge is less. And the concept that arises also in the Q&A to Sarah is important, is what is the difference between what is intentionally added and what is not intentionally added. And beside that, there is what is a direct risk on PFAS and what is an indirect risk on PFAS. If in the past this kind of concept of investigation was in packaging more regulated, or what does it mean that if I put intentionally it will be banned, and what I don't put intentionally was not banned? Now this concept is not clear at all, and this gray zone doesn't permit, to laboratory point of view, to say if something is intentionally added or non-intentionally added. If you see the regulation on PPWR and the free requirement, you can get easily that the requirement are a mirror on the analytical perspective. What does it mean? The total fluorine, it's more related to intentionally added fluorine, and the other two parameters are related to intentionally added fluorine, but also not intentionally, because the limit of 100 ppm respect the limit of 25 ppb. It's how to compare an elephant and a mouse. it's quite similar, the different, or a elephant and a cat. It depends what is the size of the animals, and therefore the knowledge that you have in your material for 100 ppm is what you put intentionally or is predictable that are present, and 25 ppb may be something that you put intentionally, but we say that something that is present in your product that is not intentionally. If you compare that with the concept of precursor, you can get easily that the investigation and the picture that are requirements on analytical point of view on PPWR is so expressive of what is intentionally added and what is not intentionally. Therefore, you have to investigate both. If you go deep in the approach of analytical perspective and point of view, you can see that the total fluorine, the total organic fluorine, cover chemicals that may be not precursor, may be not PFAS, and therefore the approach of investigation of this chemical must be done not just in one way, but in different way, with a target approach, with a precursor approach, with an extractable approach, with the non-target analysis. Not just one way is enough to investigate the question on PFAS, to be in compliance on PPWR, but also to be in general evaluation of the risk assessment. The first point is the target analysis. The target analysis of PFAS is for historical reason the most known techniques, because the investigation we start like Mérieux about 15 years ago to investigate these chemicals for problem, for some environmental discharge of material in some part of Italy, in some part of France, or in US. And therefore the knowledge on environmental point of view, especially in water and soil, on the target analysis on PFAS is so strong. And the two big techniques that we use, that usually the laboratory use, are an LCMS analysis and ZCMS analysis. You can't skip one to respect another if you would like to have a good picture about the PFAS investigation, because LCMS will cover a certain family of PFAS, the most known PFAS, and the CMS analysis will cover other kind of chemicals, or PFAS chemicals like FTOH, for example. And therefore, if you would like to have a picture of the presence of PFAS on your packaging product, you have to do both. The other point is that the PPWR, but also the new requirement and what we will face off in the next year, is not just what is PFAS alone, but what could release after degradation the PFAS. And therefore, there is another step of techniques that is the top assay. What does it mean, top assay? It's a sort of forced oxidation, forced degradation on your packaging, and check again the target analysis of chemicals. I try to break down at maximum level of technology what are the potential precursor, and investigate about that what are the chemical that after this precursor will be potentially released on the environment. Therefore, is a combination between target analysis and a pre-step of total oxidation. And beside that is a requirement on PPWR, but also is a new requirement that some NGO or other categories of investigation and public investigation are doing in this way. And you can see the iceberg question, that what you test like a single testing chemicals may be just a part of the potential release on PFAS, especially if you consider that the number on PFAS are 10,000 and the list of investigated target analysis may be at maximum now on 100, you can get that the question of precursor is very important. Break down and investigate what happens. It's an important point for the compliance, but also on the analytical point of view. The other techniques is the total fluorine. There are two big techniques for the total fluorine. Both are based on combustion, and both try to investigate the total fluorine without distinction between PFAS and non-PFAS. You try to investigate the total fluorine. Even if you do the organic fluorine, you will investigate the total fluorine by indirect way. The two big techniques are the SIC analysis, that is a combustion ion chromatography. What does it mean? Combustion, absorption, and determination by your chromatography, or bomb, combustion bore by oxygen under a high level of pressure. And what is the release of this fluorine will be investigated with different techniques, from ion chromatography to ZC feed, for example, after the derivatization. Why is important when you make total fluorine to make combustion? Because the link, the bond, the liaison between fluorine and carbon is so strong. And therefore, to break down and try to investigate the fluorine is important to be strong enough to break and make a ion of fluorine for the next investigation. Another kind of investigation related to total fluorine are the AOF and EOF analysis that are more used in the environmental point of view, is the absorbable organic fluorine or the extractable organic fluorine. It's something that evaluates what is available for the environment. If you know the regulatory that are present, for example, in Denmark about the paper-based product, they say that there is a limit of 20 ppm on the total organic fluorine or the extractable organic fluorine. What does it mean? That in the investigation on the environment was how can I say, was proposed like a sort of how is available the PFAS inside the environment system. Therefore, when you make a sort of testing plan on your packaging product, again, you can't make just one test, one target, or just the total fluorine, but you have a sort of platform of investigation. The next step that we are already doing, especially in some matrix like water or some kind of special packaging that may release in the water, are the non-target screening. Again, the number of PFAS are 10,000, are potentially 10,000. And therefore, even if you enlarge your list of target, you could increase in hundreds of target, but the risk is that you will not cover what happens. You will not cover what could be PFAS that you don't know well. And therefore, the non-target analysis on the packaging release, on the water, on another matrix is the future. Was investigated about 3 years ago in US by IPA, but now is an approach that we already do in some matrix, because some company that would like to investigate what is the risk assessment on the release on the PFAS, not just what is conventional, is related to the kind of non-target analysis that are doing by a high resolution mass with an internal dynamic library. Therefore, to summarize the testing approach, you have to work in prevention and investigation. You have to be in compliance, and therefore the investigation on total fluorine, the investigation on target PFAS are related to the compliance on PPWR, but even on your goal, on your aim, and what is the level of investigation that you would like to do. PFAS are a question of mobility, as Sarah said, but we know that a persistent analysis. But what happens when my packaging will go in the end of life of my product? It's real that is persistent, and I will find in the next step of the mobility. Why we investigated that like Mérieux some years ago? Because the PFAS is also a problem in connection with microplastics, because microplastics may contain PFAS but may absorb PFAS and release in the environment, and also be in connection with the human health, as Sarah said well. The first, how can I say, the first categories of packaging that investigate that was the compostable product some years ago, that already banned the PFAS intentionally added in your packaging, but also put a limit of total fluorine on 100 ppm, because they know that if a product is compostable and will go to the environment like a compost in the soil, and in this soil you will have vegetables, you will have fruit, you will find your packaging in your vegetable, or better, you will find PFAS in your vegetable. What we do in brief way in the last 3 years with this study, we try to use paper, contaminated paper with PFAS, and check in the water after the paper recyclability, and the paper that we'll obtain after recycling and the composting, if the PFAS present in the product will be in paper, will be in water, and will be in the plant after the use of compost. You can see after the SEPI test method, that is, you know, that is the probably the most used testing method to recyclability of paper, and we test if my paper contain PFAS, it will be present PFAS in my recycled paper, it will be present my PFAS in the water, and you can see yes. You can see that also in this specific case, the recycled paper that contain PFAS, when I will rebuild a new paper, will contain again PFAS. And the paper in the process with water, on recycling, will contain PFAS. If your packaging will not contain PFAS, you will not find PFAS. And the same happens when I make that in composting. We make the same. We make the composting process simulation. We use the compost to make the ecotoxicity evaluation of free plant, cress, tomatoes, and wet. And we check if the presence on PFAS on my contaminated paper will be a sort of mobility evaluation in my plant, and we found that. You can see in the bottom of the right part of this slide that we found that the PFAS pass through the plant. And if the plant is small, logically, the concentration on PFAS on that plant is higher. Therefore, we prove that the ban on PPWR, or the general ban on total fluorine, target fluorine, and precursor fluorine, to have a sort of free packaging, it's a sort of win-win situation, even for environment, and win also for the human health. But if I try to move the presence of my PFAS or the use of packaging, on intentionally added packaging in my product, and move to other kind of chemicals, I have to take attention on the burden shifting. I have to avoid that I move to another chemicals that have a negative effect more than the PFAS. Therefore, when I plan, when I make a design, when I make a, how can I say, a formula of my packaging, I have to keep attention on that, especially on paper, because paper in this specific time needs coating, needs barrier. If I would like to use paper instead of plastics for the food contact application, I would like to have a paper with a barrier. And if in the past I could use that, I could use PFAS to make that, now I have to change to a new material. And as you know, new materials are new, and we don't know what happens in the field of safety, in the field of end of life. There are 3 different reports that we found by OECD and at the US by the Washington, in Washington, what could be the risk, what could be a sort of picture of evaluation of the shift from PFAS to other products. And if in the first stage, for historical reason, we try to move to not ban of PFAS, but different kind of PFAS, now the change, now the perspective is to eliminate the PFAS inside your product. But there is a risk. There is a risk on performance. There is a risk on the hazard. There is a strong risk on the cost, because the cost is part of the sustainability. I can't change my chemicals if the cost is higher. And therefore, this report investigates all the situation in the hazard point of view, but also in the performance point of view, but also in the cost point of view. And they put also the final advice. And the final advice is to ban PFAS, but also to find other alternatives. What does it mean? That in the years that they wrote this report, that was 4 years ago and 2 years ago, a clear perspective of alternative was not so clear, because there are 4 big pillars on the regrettable substitution. You have to replicate the key function, and it's very difficult to substitute the PFAS. The cost is related and in correlation with the performance. The investigation of OECD found that maybe 32% more expensive. You can get that a paper or packaging company, it's a little bit afraid about this increase of the cost. And if you change the PFAS with other coating, with other chemicals, the investigation of the end of life, it could be dangerous. Not because it's dangerous what we have now in the market, but because we don't know what happens. We know less respect in the past. And a general point that please take attention, that if you change, the performance is okay, the cost is okay, and also the end of life is okay, that you have to consider also other kind of risk, like food contact, as well as Sarah tried to underline in her presentation. What are my take-home messages? PFAS may migrate in your product by direct or indirect contamination. We don't know well what are the presence in the plastic paper, in plastic and paper PFAS, especially what is not intentionally. We have not a huge experience or a huge number of data on that. The analytical test method are a compromise, and not just one test method is able to investigate and give you a right picture of the situation. You have to use different test method, as PPWR suggested, but also other test method that will come in the future. You have to work to build a new packaging for the future. You have to substitute the PFAS, but take attention on the end of life and the risk in general. Because as you see in our project, if you put something in your packaging and is persistent, you will find it in the water, in the new packaging, and in what you will eat in the future that are regulated as well. Thank you.
Thank you, Andrea. We have some questions for you coming in via the chat. Is there a method to identify the presence of PFAS? Or in general, not, no, it's not that, sorry. Oh, yes, it is. Is there a method to identify the presence of PFAS without destroying the material, like spectrometry to be put on the sorting line of a recycling plant, for example?
Now there are some technology that will arrive in the future. What is the risk? There are some technology for the total fluorine, like PJ or whatever. But what is the risk? The risk that you have to correlate the sensitive of the test method respect to what is your goal, because probably we will have techniques that will make a screening, like a sort of sorting system, but they will investigate a high level of PFAS present, a high level of total fluorine probably presence. They will be not enough good to reach 25 ppb. Take attention on that limit. I said that in food there are a regulation on PFAS ban, and they investigate in food PPT, part per trillion. It means that the perspective for the future is to be sensitive more that we are investigating now.
Sorry.
No problem.
And we have another question. Given that the restriction in PPWR cover both intentionally and unintentionally added PFAS, can we say that packaging supplier must provide an analysis, not just a statement that they do not use PFAS?
Yes, it's perfect. You get the point. If by now the most part of the declaration, you know that there is a system of supply chain declaration along the packaging supply chain, and by now was enough to say that I will not use intentionally added PFAS. Now this word it's okay say is not enough, because 25 ppb will not discriminate if you put intentionally or not intentionally. 25 ppb may be not intentionally or intentionally as well. You have to prove by testing, because the limits are number, not declaration.
Okay, thank you. We have one last question. Are these methods EU harmonized standards for plastic paper packaging, or to be? So in order to comply to the PPWR PFAS restriction, all packaging supplier/producers needs to analyze the PFAS content in the packaging. Is this feasible number of packaging materials time-wise? It's a long question. Do you want me to?
Yes. I will try to summarize.
Okay, thank you.
The first point is not harmonized at all. If I mean harmonized, that are quoted in the regulation are not an official standard about that. But about that, some working group are working to make an harmonized approach. For example, I'm part of the same working group that are working on the total organic fluoride determination on paper packaging product. Therefore, it will be ongoing. But again, you get that the timeline of August of the next year is not too far. And therefore, you have to start the investigation. The harmonized test method, the list of approach, what does it mean precursor will come? But the timeline to make a picture of your product, it's not too far. You have to start now. Otherwise, you will find that your product will contain PFAS, and the time to split, to change, and to move to other technology is too short for the industrialization.
Okay, great. Thank you very much, Andrea, for your presentation and for answering the questions. And thanks again to Sarah. I think we can end this webinar here. Thank you everyone for being here, for listening. As I said at the beginning, you will receive the slides and also a link to see the replay, and it will also be put on Fost Plus website. I'm sorry that some of you had some issues to connect and to join the webinar. It's a technological thing. I don't really know what happened, but for those who would hear, thank you. Thank you very much to our speakers, and see you next time for another webinar. Thank you very much, everybody.